All right, welcome to the deep dive, everybody. Ready to get philosophical today. We're going deep on something called, get this, infinite regress arguments.
Oh, yeah. These are fun. It's basically, imagine you know how a kid will ask why about something? And then no matter what you say, they just keep asking why.
Oh, yeah. Why drives you nuts?
It's like that, but in philosophy, it's not just being annoying. It can actually point out some seriously tricky stuff about our theories, like, do they actually make sense? Or are they just leading us on this endless loop of explanations?
I'm in. Let's break it down. So
Okay.
I've been reading up on this, mostly in the Stanford Encyclopedia of Philosophy. They've got a whole bunch on this, and they really get into the nitty-gritty of, like, how these arguments have been used historically and all the different ways they play out.
Yeah, it gets pretty wild.
But for our deep dive today, I thought it'd be cool to focus on two big things. First, like, when does one of these infinite regresses actually mean there's a real problem with an idea? You know?
Yeah.
Because sometimes it's just like, oh, things go on forever, and maybe that's okay.
Right, exactly.
And second, let's see if we can spot those aha moments, those points where you're like, oh, I get why that argument is so powerful, or I see why that philosopher is freaking out about this endless chain.
Sounds good.
Awesome. So let's jump in. Let's start with how an infinite regress can actually expose something wrong with a theory, something beyond just the fact that it goes on forever.
All right, so think of it like this. Sometimes the infinite regress isn't the main problem. It's more like a symptom of a deeper issue.
Right, like a flashing red light.
Exactly. And a classic example of this is the third man argument, which was used to critique Plato's theory of forms. Now, just a quick recap for anyone who needs it. Plato believed that whenever we see multiple things that share a characteristic, like, let's say, a bunch of red apples,
Yeah, makes sense.
he said that's because they're all participating in a perfect, eternal form of redness. These forms, they're kind of like blueprints.
The ultimate ideal.
Right, exactly. And these forms were thought to be self-predicating, meaning the form of redness itself would be red. And it's separate. It's distinct from the actual apples.
Okay, so far so good. I'm following.
But here's where it gets tricky. If those apples are all red because they're participating in the form of redness, and the form of redness is itself red, then the apples and the form now share a quality. They're all red.
Okay, wait. I'm starting to see where this is going.
Mm-hmm.
So if they all share a quality, shouldn't there be another form to explain that? Like a form of redness version 2?
You got it. We'd need like a redness oneness to explain why they're all red together. But then redness oneness is also red because, remember, forms are self-predicating. So now we have the apples, redness, and redness oneness all sharing the quality of redness, which means we need a redness two-ness and on forever.
It's red all the way down.
Exactly. It's red all the way down, and that's the infinite regress. But here's the kicker. This infinite chain isn't just a quirky side effect. It's showing us that Plato's theory has a major flaw, a contradiction at its core.
Ooh, okay. Lay it on me.
Think about it. If redness is red, self-predication, then it should participate in itself, right? Because anything that's red participates in the form of redness.
Right.
But Plato also said forms are distinct from the things that participate in them. So redness ends up both participating in itself and being distinct from itself, which is a big no-no in logic.
Oh, wow. So it's not just that there might be infinitely many forms, it's that the theory itself leads to this nonsensical idea that something can be both distinct from itself and part of itself at the same time.
Exactly. The infinite regress is a red flag, but the real problem is the contradiction lurking behind it. And as our source points out, this shows us that sometimes the worry with an infinite regress isn't the infinity itself, but the fact that it can expose some deeper flaw in the way we're thinking about things.
That makes a lot of sense. So it's not about being afraid of infinity. It's about using it as a tool to examine our ideas more closely. Like, hey, is this theory leading to something absurd?
Right. Now, this also brings us to the idea that sometimes an infinite regress might point to what we call a local theoretical vice. It's a problem that's specific to a theory's goals or the stuff it's talking about.
Oh, interesting. Okay, so like some infinities are fine, but others are bad, depending on the context.
Exactly. Like an infinite number of things isn't always a deal breaker in philosophy. Take the natural numbers 0, 1, 2, 3, and so on forever.
Right.
We usually accept that there are infinitely many of them.
Yeah, we don't really bat an eye at that.
No, because in math, it's kind of baked into the system. But now, contrast that with, say, an infinite regress of causes for every event. Here's the basic idea. Every event has to have a cause, right? And the causes relationship has some specific rules. Nothing can cause itself that's called irreflexive.
Okay, makes sense.
Then, if A causes B, B can't cause A that's asymmetric.
Right, no, going back in time.
And lastly, if A causes B and B causes C, then ultimately A causes C that's transitive.
Okay, so causes have a clear direction.
Exactly. Now, if you start with just one event and follow this chain backwards, you quickly end up with an infinite chain of causes, each one causing the one before it.
Okay, but why is that a problem? It's just things happening, right?
Well, here's the local vice. Unlike with the infinite natural numbers when it comes to the past, we have some pretty strong scientific reasons to believe it's not infinite. Like, the Big Bang theory suggests the universe had a finite beginning.
Right, so an infinite chain of causes doesn't really sit with our current understanding of the universe.
Exactly. Trying to squeeze infinitely many causes into a finite amount of time gets really tricky, especially since there's also evidence suggesting that time itself might have a smallest possible unit, a kind of quantum of time. This would make fitting in infinitely many events before a certain point even more problematic. So, both sequences are infinite numbers and causes, but one seems to clash with how we think the world works while the other doesn't.
So it's like the infinity of numbers is a feature, not a bug, but the infinity of past causes is a bug because it creates a conflict with other things we think we know.
Exactly. It's all about context.
Yeah.
Now, sometimes an infinite regress might not be about contradictions or empirical evidence, but it might just suggest that a theory isn't really explaining what it sets out to explain.
Oh, interesting, like it's spinning its wheels.
Right. It's like, okay, you've given me an infinite chain of steps, but I still don't understand the core concept. A classic example of this is Bradley's regress on predication. The question is, what does it even mean to say A is F, like the sky is blue?
Right, what's connecting those two things?
One way to think about it is there's this property of blueness, and the sky is somehow connected to it.
Okay, yeah, that seems reasonable.
But wait, now we have a new statement that needs explaining. The sky is connected to blueness. If the first statement needed explanation, this one seems to need it just as much. So maybe we introduce a relation that links the sky and blueness. We could call it instantiation.
Okay, so the sky is instantiated with blueness.
Yeah, something like that. But then we have another statement that needs explaining. Instantiation links the sky to blueness.
Oh, I see the problem. We just created a new is statement that needs the same kind of explanation, so we'd need another relation to link that relation, and so on forever. It's like using a word to define itself. You're not really getting anywhere.
Exactly. It's an infinite regress of relations, each one needing the same kind of explanation as the one before. Now, whether this regress is actually a problem depends on what we're trying to do with our theory of predication.
So what are we trying to do?
Well, if we're aiming for an analysis where we break down predication into simpler, more fundamental parts that we already understand, then this regress is bad news. We haven't really gotten any closer to understanding what is means.
Right. It's like saying we understand running because it's an instance of motion, but then explaining instance of by just saying it's another instance of something else. We're going in circles.
Exactly, but as our source points out, if our goal is just an ontological account where we want to describe what makes true predications true, then maybe the regress isn't so bad. Maybe the single fact of the sky being connected to blueness is enough to ground all those infinite statements, even if it doesn't break them down into simpler pieces.
So it's like the is still a bit mysterious, but we know it's doing something in the world.
Exactly. It has a grounding, even if we don't fully grasp the how. Now, another cool example of this is McTaggart's regress argument against what's called the A series of time. This is the intuitive idea that time flows, that there's a past, a present, and a future.
Right, time's arrow and all that.
Yeah. But McTaggart argued that if every moment has been present, is present, or will be present, then every moment has all the A properties past, present, and future, and that seems contradictory. A moment can't be both past and future at the same time.
Okay, but the obvious response to that is that a future moment will be present, and then it will be past. It's not like it's all those things simultaneously.
Right, exactly. But McTaggart was a clever guy. He said, fine, but that just creates a second-order A series. Now we have properties like past future, past present, and present past, which also seem incompatible with each other, and so on.
You just get another infinite regress, just at a higher level.
Exactly. Now, Whether this really destroys the A theory of time is up for debate.
Mm-hmm.
Some philosophers think it shows that any attempt to talk about time in terms of past, present, and future will inevitably lead to these infinite contradictory chains.
But others aren't so convinced, right?
Right. They might say that McTaggart's making a mistake at each step, like maybe he's misunderstanding what it means for something to be a certain way versus it having been or will be that way. If you accept the basic idea that time flows and things change, then the fact that a moment was future and is now present isn't necessarily a contradiction.
So it comes down to how you view time itself.
Exactly. If you're already skeptical of the idea that time really flows, then McTaggart's regress is going to seem like a fatal blow. But if you're comfortable with the idea of temporal succession, things changing over time, then the regress might not seem so bad. Again, our background philosophical assumptions play a huge role in how we interpret these infinite chains.
Fascinating stuff. So sometimes the regress itself is the problem, like when we're looking for a foundational explanation for something.
Exactly. This is where we get into foundationalism and coherentism. The basic worry is, if explaining why x is f always involves pointing to another x that is also f and that goes on forever, then it feels like we're never really getting to the bottom of things.
Yeah, like the explanation just keeps getting pushed back further and further. And it's like, will we ever find a solid ground to stand on?
That's the concern. And there are a few ways to deal with it. Foundationalism says there's got to be a base level, something that's F just because, something that doesn't need further explanation and can explain everything else.
Like a bedrock principle.
Exactly. Now, coherentism, on the other hand, says maybe it's not about a single foundation, but more about how all our explanations fit together, like a web of interconnected ideas.
So no single piece is the key. It's the overall structure that makes it work.
Right. And then there's infinitism, which is more like, hey, maybe an infinite regress is fine, let's just roll with it.
That seems bold. But okay, let's get concrete here. Give me some real-world philosophical examples where this plays out.
Okay, so in metaphysics, we often talk about ontological dependence, the idea that things depend on other things for their existence, like a table depends on its legs, and the legs depend on the wood they're made of, and so on.
Right, the building blocks of reality.
Now, some philosophers, like Leibniz, thought that if this chain of dependence goes on forever, then it's like nothing has any real ultimate being. It's like an endless chain of borrowing sugar. Where did the extra bag of sugar even come from in the first place?
I love that analogy. Like the source just kind of disappears into this infinite chain.
Exactly. And this is a big motivation for foundationalism in metaphysics, the idea that there have to be some fundamental independent things that aren't dependent on anything else, and they're what give everything else its reality.
So like fundamental particles or something.
Could be, or something even more abstract, like pure energy, or even God, depending on your metaphysical flavor.
Okay, I'm seeing how foundationalism tries to solve that problem.
Now, a cool thing to note here is that the direction of dependence matters. Like, a set, depending on its members, and those members depending on other members, isn't usually seen as a big problem because the dependence is going from the smaller, simpler stuff to the bigger, more complex stuff.
Yeah, that seems less worrisome.
But when the dependence goes the other way, like, if every part of something always had even smaller parts, and that went on forever, that's when things get tricky. That's what's sometimes called gunk, and it makes people wonder, what's the ultimate reality here?
I see. So like, is the whole universe just made of smaller and smaller things forever, or is there some ultimate smallest unit that everything is built from?
Right. Jonathan Schaeffer, for example, thinks maybe we should flip the script entirely and say that the whole universe is fundamental, and the parts actually depend on the whole.
So like the universe is the sugar and everything else is just borrowing from it.
You got it. Now, in epistemology, the theory of knowledge, we have a similar regress with the justification of beliefs. If every belief needs a reason to be justified, and that reason needs a reason, and so on forever, it's like, do we actually know anything at all?
Oh man, that's a scary thought. Like, is everything just built on sand?
That's the worry. And this leads to two main camps: foundationalism and coherentism. Foundationalists say there have to be some basic beliefs that are justified just by themselves, and they can then be used to justify other beliefs.
So like self-evident truths or something.
Yeah, exactly. Something like I exist, or 2 + 2 = 4. These are just be so basic that you don't need a reason for them, they just are.
Okay, so that's foundationalism's way out of the regress. What about coherentism?
Coherentists say that justification isn't about individual beliefs being grounded in some foundation, but rather about how well all our beliefs fit together, how coherent they are as a whole system.
So like a belief is justified if it fits in with all our other beliefs. and doesn't contradict anything else we hold to be true.
Exactly. A good analogy here is the difference between a pyramid and a raft. Foundationalism is like a pyramid, where those basic beliefs are the strong base that supports everything else. Coherentism, on the other hand, is like a raft. No single plank is essential, but the whole thing stays afloat because all the planks are connected and support each other.
I like that. So the strength comes from the interconnectedness, not from some ultimate foundation.
Right. Now, even in ethics, we see this play out. Aristotle argued that it can't be the case that everything good is good only because it aims at something else that's good. If that were true, he said, then all our desires would ultimately be pointless, leading to an infinite regress of wanting things for the sake of other things.
Yeah, like what's the point of it all if it just keeps going forever?
Exactly. And his solution was to propose a highest good, something that's desired for its own sake, and that can then ground the goodness of everything else. This is another type of foundationalism, but in ethics.
So like happiness or flourishing or something that's inherently valuable in itself.
Right. So we see these infinite regress arguments popping up all over philosophy, pushing us to think about whether we need some kind of foundation or a coherent system to really make sense of things.
It's like infinity is a challenge, but it's also an opportunity to get to the bottom of some really fundamental questions.
Exactly. Now, let's shift gears a bit and talk about local versus global explanations in the context of regresses. Sometimes we can explain why a particular thing has a certain property by pointing to something else, but that might not tell us why that property exists at all.
Oh, interesting. So like we can explain the local instance, but not the big picture?
Right, like imagine you're explaining why a particular link in a chain is made of metal. You could say, well, it's attached to another metal link and so on.
Okay, so that explains why that specific link is metal, but not why metal links exist in the first place.
Exactly. And Fiona Bliss, for instance, argues that this is a problem for ontological dependence. In an infinite regress of things depending on other things, each individual thing's existence is explained by the thing it depends on, but the existence of the entire chain remains unexplained.
Like, we can trace the chain backwards forever, but we never find out where it began.
Right. It's like the sugar borrowing thing. Again, we can explain where each person got their sugar from, but not why there's this infinite cycle of borrowing happening at all.
It's like who baked the first cake?
Exactly. And Graham Priest makes a similar point with his example of an infinite series of active and passive objects. Each object's state, whether it's active or passive, is explained by the one before it, but there's no explanation within the system for why the whole thing is in a particular state.
So it's like, why is everything active instead of passive?
Right. It's like we have local explanations for each individual thing, but no global explanation for the overall pattern.
I'm getting the sense that whether a regress is bad or not really depends on what we're trying to explain. Like, if we're just curious about this one particular thing, then maybe an infinite regress is fine. But if we want to understand the big picture, then we might need something more.
You got it. And sometimes, even if a regress isn't contradictory or doesn't necessarily fail to provide a local explanation, it might still be seen as less desirable because it lacks what we call theoretical parsimony. This is the idea that all other things being equal, simpler explanations are generally better.
So like Occam's razor.
Yeah.
The idea that the simplest explanation is usually the best.
Exactly. And a classic example of this is Daniel Nolan's Infinite World Turtles. You could maybe imagine a scenario where the Earth is resting on an infinite stack of turtles, each one standing on the one below it.
Yeah, I've heard that one.
It's not necessarily logically impossible.
Right. But it just seems kind of ridiculous.
Exactly. It's ontologically extravagant. Like, why would there be infinitely many turtles when a much simpler explanation would do? It feels unnecessarily complex.
It's like, okay, sure, you could explain it that way, but why make things so complicated?
Right. David Lewis, though, thought differently about parsimony. He said maybe we should focus on having fewer kinds of things, not necessarily fewer individual things of the same kind. But Nolan argues that even quantitative parsimony, wanting fewer things overall, is a valid way to judge theories, especially when they're trying to explain the same thing.
So turtles bad, simpler explanation good.
Basically. And Ross Cameron applies the same idea to ontological dependence. He says even if each thing in an infinite chain is explained by the thing it depends on, it still feels less elegant than having a fundamental level of reality that grounds everything.
So one foundation is better than infinite dependencies because it's simpler.
That's the idea. Now, this all ties into Bob Hale's distinction between transmissive and non-transmissive explanations. In a transmissive explanation, the fact that x2 has property f is essential for explaining why x1 has property f, and this dependency goes all the way down the chain. Infinite transmissive regresses are usually seen as problematic because the explanation for the original property never really gets grounded, it just keeps getting passed along.
So it's like a hot potato explanation that never stops.
Exactly. But in a non-transmissive explanation, x1's property might be explained by x2, but x2's property isn't necessary for the explanation to work. In these cases, an infinite regress might be okay.
Okay, so it's like x2 is just incidentally f. It's not why x1 is f.
Exactly. Now, a really cool example of this is Blackburn's dilemma about explaining necessity. Necessary truths are things that have to be true, like the laws of logic.
Right, they can't be any other way.
Exactly. But if you try to explain a necessary truth with a contingent truth, something that could be true or false, then it seems like you've undermined the necessity of the first truth.
Right. Like if 2 plus 2 is explained by something that might not be true, then 2 plus 2 equals 4 might not be true either, which doesn't make sense.
Exactly. But if you explain it with another necessary truth, then you seem to get an infinite regress of necessary truths needing explanation. Now, Hale's solution is to say that maybe the necessity of the explainer isn't always crucial to why it explains.
So like maybe a contingent truth can still explain a necessary truth as long as it's not explaining it because of its contingency.
Right. He uses the example of explaining the necessity of a logical rule like A and B is true only if A is true and B is true. He says the fact that this rule itself is necessary isn't why it explains the necessity of a conjunction.
Okay, my brain is bending a bit, but I'm kind of following.
The key is sometimes the necessity of the explainer isn't doing the heavy lifting in the explanation. Now, this idea also shows up in epistemic infinitism, the view that our justifications for beliefs can go on forever.
So like there's always another reason behind the reason and so on.
Right. But Peter Klein argues that even if belief P is justified by reason R1 and R1 is justified by R2 and so on, the justification of R1 doesn't depend on the justification of R2 in a transmissive way. Like maybe the link between them is probabilistic or something else that doesn't require R2 to be fully justified for R1 to be justified.
So it's like R1 is a good reason even if we're still figuring out R2.
Exactly. The dependence isn't as tight. And this seems to be a difference between ontological dependence where A depends on B because B exists, and reasons for belief, where a reason can be good even if we haven't completely justified it yet.
Okay, I'm getting the sense that there are different kinds of dependence, and that affects whether an infinite regress is a problem.
Right on. Now, finally, let's talk about how coherence, circularity, and holism can help us deal with these regresses.
So these are ways of thinking about justification and explanation that don't rely on a single foundation.
Exactly. Coherentism in particular says that justification comes from the overall interconnectedness of a system, not from individual elements being grounded in something else.
So it's about the big picture, not the individual pieces.
Right. Now, simple circular explanations like X is true because Y is true and Y is true because X is true, those are usually not very helpful.
Yeah, it feels like we're just going in circles there.
Right. But holistic explanations are more sophisticated. For example, Lawrence Bonjour's version of coherentism says that a belief is justified if it fits in with all our other beliefs and contributes to the overall coherence of our entire belief system. It's not about individual beliefs having their own little foundations, it's about the system as a whole making sense.
So, like, a single belief might not be super strong on its own, but it gains strength from being part of a larger, coherent web of beliefs.
Exactly. Now, a cool example of this in action is J.J.C. Smart's Regress argument against the passage of time. He said, if time flows, then it must have a rate of flow, right? But then to measure that rate, we'd need another time scale, and to measure that rate, we'd need another time scale, and so on forever.
So it's like, how fast is time flowing? Well, we need another time to compare it to, and another time to compare that to, and it just keeps going.
Right. But John Markosian offers a coherentist response to this. He says, a rate is just a comparison between two changes. So we can talk about the rate of time passing relative to other things that change, like the Earth's orbit, without needing an infinite series of timescales.
So, like, we don't need a special time measuring time. We can just compare time to other processes in the world.
Exactly. He says, the grounds for time's passage might lie in the interconnected nature of time itself, not in some relation to another more fundamental time dimension. It's about understanding things through their relationships within a system.
So it's like, instead of needing a foundation, we find coherence and explanation within the system itself.
That's the idea. So as we wrap up our deep dive into infinite regress arguments, it's clear that these are some seriously powerful tools in philosophy.
Yeah, they really make us think hard about how we explain things, what counts as justification, and what the fundamental nature of reality might be.
And the big takeaway is that there's no easy answer to whether an infinite regress is always bad. It really depends on the specific context, the goals of the theory we're looking at, and our own philosophical assumptions.
Right. And there are a lot of different ways philosophers have tried to deal with these regresses. Some reject the premises that lead to them, others propose foundations, some embrace coherentism, and some even defend infinitism in certain cases.
So for all of you listening, I challenge you. Next time you come across an explanation that seems to go on forever, whether it's in philosophy, science, or even everyday life, ask yourself, is this regress actually a problem? Or is it maybe telling us something interesting about the way things are connected?
And here's a final thought to chew on. Could it be that our fear of infinite regresses sometimes stops us from exploring ideas that are complex, but ultimately worth thinking about? Maybe sometimes the endless chain isn't a dead end, but a path to a deeper understanding of the world. Thanks for joining us on The Deep Dive.